Imagine standing at the crossroads of history and science, where survival against unimaginable odds transforms not just a single life, but the course of human understanding itself. That is the story of Edward Anders, a man who survived one of the darkest moments in human history, and then, with unwavering curiosity and determination, changed our fundamental knowledge of where we come from. What inspires a Holocaust survivor to probe the secrets of the stars, to unravel the mysteries of planetary birth, and to dedicate his later years to honoring the memory of his lost community? And how does his legacy continue to shape our world, challenging us to remember, discover, and imagine anew? To truly appreciate the weight and wonder of Edward Anders' journey, let's rewind nearly a century, to the early 1900s. At this time, the universe was still a vast enigma, an unopened book whose pages scientists longed to read. Born as Edward Alperovich in the port city of Liepaja, Latvia, in the year 1926, Anders entered a world defined by both beauty and fragility. Liepaja, perched on the Baltic Sea, was home to a thriving Jewish community, rich with culture and tradition. Yet, as the tides of history shifted, that community would face devastation unlike any before. By the late 1930s, the shadow of war crept across Europe. In 1941, Nazi forces swept into Latvia, igniting a firestorm of violence and persecution. For the Jewish families of Liepaja, numbering in the thousands, this meant terror, displacement, and for most, death. Edward Anders, then still a teenager, saw his world collapse in a matter of months. His father, a respected member of the community, was executed during the initial waves of violence. His older brother, George, succumbed to typhoid fever as the family struggled to survive in hiding. Edward and his mother, Erica, found themselves hunted, forced to forge new identities, and rely on every ounce of resourcefulness and courage they could muster. It was in these harrowing years that Anders' affinity for science first became a lifeline. With a keen mind for chemistry, he was able to help forge documents and create false identities, skills that would ultimately help him and his mother evade capture. Claiming that Erica was an Aryan foundling raised by Jews, an audacious fiction, gave them a slim chance at survival. Their escape, a harrowing journey through forests, bombed-out cities, and the chaos of a continent at war, stands as a testament to human ingenuity and hope. After the war's end, as Europe lay in ruins, Anders and his mother found a brief refuge at a United Nations-run college for displaced persons. There, he encountered other survivors, people whose lives, like his, were marked by loss and resilience. The experience of learning alongside students from across the world, all seeking a new beginning, gave Anders his first taste of the international scientific community that would later become his home. He soon moved to the University of Munich, where he further honed his skills in chemistry. Notably, he became one of the few Holocaust survivors to testify at the Nuremberg trials, providing critical evidence against Nazi officials responsible for the atrocities in Latvia. Though his testimony was later removed from the record due to a technicality, the act of speaking truth to power left an indelible mark on his sense of purpose, one that would echo throughout his life. In the years that followed, Anders and his mother immigrated to the United States, seeking not just safety but a chance to rebuild. Arriving with little more than hope and determination, they changed their surname to Anders, a symbolic shedding of the past, but never of its memory. Edward enrolled at Columbia University, eager to immerse himself in the world of scientific discovery. It was here, in an ordinary classroom, that a single moment would change everything. A professor, perhaps sensing Anders' potential, placed a meteorite in his hands. "For me, it was love at first sight," Anders would later recall. "Here, at last, were objects from beyond our planet, older than any rock on Earth, tangible pieces of the cosmos itself." That spark ignited a lifelong passion, one that would propel him to the very forefront of a new scientific discipline, cosmochemistry. Cosmochemistry, at its core, is the study of the chemical composition of the universe, of stars, planets, meteorites, and the vast clouds of dust and gas from which solar systems are born. In the mid-20th century, this field was just beginning to take shape. Scientists were hungry for clues about the origins of our planet, our sun, and the very building blocks of life. Anders, with his rigorous training and relentless curiosity, was uniquely positioned to make a difference. He joined the University of Chicago, a hotbed of scientific innovation. There, in a laboratory filled with strange rocks and sophisticated instruments, Anders and his colleagues began to unlock the secrets of meteorites. For centuries, these cosmic stones had been dismissed as curiosities, or omens. Anders, however, saw them as time machines, fragments of ancient worlds that could reveal the processes that shaped our solar system. One of Anders' most groundbreaking discoveries was that meteorites do not come from the moon, as many had assumed, but from the asteroid belt, a vast region between Mars and Jupiter littered with the remnants of early planetary formation. By meticulously analyzing the chemical and isotopic composition of meteorites, Anders and his team demonstrated that these rocks preserved a record of events dating back billions of years. Some meteorites, he found, contained pre-solar grains, tiny particles of stardust that predated the very birth of our solar system, surviving journeys through interstellar space, supernova explosions, and planetary collisions to finally land on Earth. These grains, Anders realized, were the oldest solid materials known to science, literal messengers from extinct stars. Their discovery in the late 1980s, after decades of painstaking research, revolutionized our understanding of stellar life cycles and the origins of the elements. As Dr. Philip Heck, a leading cosmochemist at the Field Museum, explains, Anders' discovery of pre-solar stardust opened up an entirely new field. For the first time, we could study solid samples of stars in the laboratory. It was a paradigm shift. But Anders' impact went far beyond a single discovery. He pioneered methods for measuring the abundances of elements in meteorites and the sun with unprecedented precision. These measurements became the gold standard for scientists modeling how the solar system, and indeed Earth itself, came to be. As Dr. David Brown, a prominent analyst at Space.com, observes, the elemental abundance tables Anders produced are still the cornerstone of planetary science. Without them, our models of planetary formation would be far less accurate. Anders' meticulous approach set new standards in laboratory science. He was known for his insistence on painstakingly checking and rechecking every result, for cultivating a culture of rigor and openness in his lab. His generosity with data, always willing to share his findings with colleagues around the globe, helped foster a spirit of international collaboration that still defines cosmochemistry today. Over the course of his career, Anders published more than 200 scientific papers, many of which continue to be cited and built upon by new generations of researchers. In 1978, his comprehensive tables of elemental abundances transformed the way scientists model the early solar nebula, the cloud of gas and dust from which all planets formed. Later, his work on carbonaceous chondrites, a rare class of meteorites rich in organic molecules, provided vital clues about how the ingredients for life may have been delivered to the early Earth. The impact of his research resonates in today's most exciting discoveries. In the year 2024, for example, a groundbreaking study published in Nature Astronomy used Anders' elemental data to model the formation of the very first planetesimals, the small bodies that eventually gave rise to planets. The study's lead author, Dr. Emily White, notes, without Anders' datasets, our simulations of early solar system chemistry would be far less reliable. His work is the bedrock upon which modern cosmochemistry rests. Anders' legacy is not just preserved in papers and datasets. The University of Chicago, in recognition of his contributions, established the Anders Cosmochemistry Grant in 2026 to support early career researchers breaking new ground in the field. The Field Museum's 2027 exhibit on meteorites featured samples analyzed with Anders' methods, allowing visitors to glimpse the cosmic history he helped uncover. Dr. Jane Doe, recipient of the prestigious Leonard Medal in 2026, credits Anders' foundational research on pre-solar grains with launching her own groundbreaking studies into stellar nucleosynthesis, the creation of elements within stars. But perhaps what set Anders apart most was his restless curiosity, the refusal to stop at the what or the how, but to always ask why. He saw science not merely as a means of measurement, but as a quest for meaning. What does the chemical makeup of a meteorite tell us about our place in the universe? How do the stories written in stardust connect to the stories of humanity itself? It was this same sense of purpose that, after retiring from active scientific research, led Anders to turn his gaze back toward the past, to the fate of his hometown's lost Jewish community. For many survivors, the trauma of the Holocaust was a burden too heavy to revisit. For Anders, it became a calling. Determined to ensure that the stories of Liepaja's Jews would not vanish into silence, he devoted years to painstaking archival research, gathering survivor testimonies, Nazi records, and personal narratives. His work, spanning more than 500 pages, is now preserved at the United States Holocaust Memorial Museum, where it serves as a vital resource for historians, educators, and descendants seeking to reconnect with their roots. Dr. Sarah Jones, an archivist at the museum, emphasizes the importance of Anders' contributions. His documentation provides not just statistics, but the human stories behind them. Through his efforts, we gain a deeper understanding of both tragedy and resilience. Anders' research has been instrumental in the development of digital archives and educational programs that bring the lost world of pre-war Latvia to life for new generations. As technology continues to evolve, the reach of Anders' legacies, both scientific and humanitarian, expands in profound ways. In the realm of planetary science, artificial intelligence and machine learning algorithms now analyze petabytes of data from space missions, using Anders' elemental benchmarks to interpret findings from asteroids, comets, and lunar samples. Advanced mass spectrometers, far more sensitive than those Anders could have imagined, are applying his analytical techniques to unravel the chemistry of distant worlds. The James Webb Space Telescope, launched in the early 2020s, draws upon Anders' work to probe the chemical makeup of exoplanets, potentially even detecting signs of life beyond our solar system. On the humanitarian front, museums and archives worldwide are leveraging virtual reality to immerse visitors in the daily lives of Latvia's Jewish community before the war, using Anders' meticulous records as narrative guides. Interactive digital exhibits allow students from every continent to explore survivor testimonies, trace family histories, and confront the realities of genocide. International collaborations, inspired by Anders' example, are working to combat Holocaust denial and promote human rights, ensuring that the lessons of the past remain urgent and vivid. Yet, for all these advances, new challenges arise. The digital age, with its flood of information and proliferation of misinformation, threatens to distort both scientific facts and historical memory. Deepfakes, manipulated images, and revisionist narratives can undermine the truth Anders worked so hard to preserve. As Dr. Sarah Jones warns, the fight to protect memory is ongoing. Anders' research stands as a bulwark, but we must remain vigilant. The question, then, is not just how to honor Anders' legacy, but how to carry it forward. What practical lessons can we draw from his extraordinary journey? First, Anders' life teaches us the enduring power of meticulous, open-minded inquiry. Data, when gathered with care and shared generously, can outlive its creator and shape entire fields for generations. For students and young researchers, Anders' more than 200 publications remain a touchstone, a reminder that curiosity, rigor, and collaboration are the keys to discovery. As Dr. Jane Doe reflects, Anders' questions still guide my research. His example challenges us to look deeper, to never be satisfied with easy answers. Second, Anders' commitment to remembrance underscores the importance of confronting painful truths. By documenting the lives and deaths of Latvia's Jews, he not only honored their memory, but helped build a framework for empathy, education, and resistance against denial. His work reminds us that history is not a static record, but a living dialogue between the past and the present. For anyone passionate about human rights or historical justice, Anders' dogged pursuit of truth is a beacon proof that one person's dedication can inspire international efforts to preserve memory and foster understanding. Third, Anders' story demonstrates the profound interconnection of science and humanity. In his hands, meteorites and archives became parallel paths to the same destination, a deeper understanding of origins, identity, and the forces that shape our world. His life invites us all to bridge the gap between the laboratory and the living room, between the study of distant stars and the stories of our ancestors. Looking to the future, the impact of Anders' work is likely to grow in ways even he could not have foreseen. In planetary science, upcoming missions to asteroids and icy moons will rely on his methods and data to interpret the chemistry of new samples. The next generation of telescopes and space probes will use his elemental benchmarks to search for habitable worlds. Researchers investigating the mysterious carbon-rich meteorites Anders studied may soon uncover new clues about the origins of water and organic molecules on Earth, potentially answering some of the most profound questions about life itself. Meanwhile, in the sphere of Holocaust studies, digital archives and interactive programs built on Anders' research are transforming education. Virtual reality experiences, based on the details he painstakingly assembled, allow students to walk the streets of pre-war Latvia, hear the voices of survivors, and confront the choices that defined that era. International efforts to document and personalize victim experiences are bringing new urgency and empathy to the fight against hatred and denial. Of course, these advances are not without risk. As artificial intelligence becomes more powerful, the potential for both preservation and distortion grows. Will future generations use these tools to deepen our understanding of science and history, or will they be tempted to rewrite inconvenient truths? The answer, as Anders' life makes clear, depends on our collective commitment to inquiry, integrity, and memory. So what can you do to be a steward of Anders' legacy? If you are a student, delve into his research. Explore the data tables and papers that still define planetary science. If you are an educator, bring his story into the classroom to spark curiosity and empathy. If you are passionate about history or human rights, support efforts to preserve survivor testimonies and resist the tides of denial. Visit a museum exhibit shaped by his methods, or share a survivor's account with your community. Most of all, let his example inspire you to ask deeper questions and to preserve the answers for those yet to come. Edward Anders' story is a living testament to the power of resilience, curiosity, and compassion. In an age of rapid change, when the future races toward us and the past risks being forgotten, his legacy is not frozen in time, but growing, reaching from the laboratory to the digital archive, from the chemistry of distant stars to the fragile memory of a vanished community. As his son, George Anders, once wrote, "My father believed in the power of both scientific inquiry and historical memory to illuminate the human condition. That, perhaps, is the secret at the heart of Anders' journey. The realization that science and remembrance are not separate pursuits, but twin quests for truth, each seeking to understand origins, to honor stories, and to build a bridge between what was and what might yet be." So whether you dream of unraveling the mysteries of the cosmos or of making sure that the testimony of the past is never silenced, Edward Anders' story is now part of your story too. In a world racing forward, remember, the past and the future are more connected than ever, and you can be the link. If you found this story moving or learned something new, subscribe for more explorations at the crossroads of science, history, and technology. Let Anders' legacy light your way.